Hey everybody, Marco here, and welcome to another pencil mark video. I don't know why I thought this one was a good idea, but here I am. We've got a cipher Japanese sums. I already did a Japanese sums puzzle on this channel a little bit earlier, but the quick rules are that we have to place a number from a specified list over here, in this case, 1 to 7 in this puzzle, into the grid so that, like in Sudoku, a number doesn't appear more than once in each row or column. The numbers, usually they're numbers, on the outside of the grid represent the sums of continuous groups of numbers. And between these groups of numbers, there's empty cells, which we can just X out. In this case, a few X's are given. This is not always the case, but yeah. This puzzle has a special twist where the clues on the outside are ciphered. So we've got A, B, C, D, E, F, G, H, I, J. Why is the alphabet so hard? These are each a unique number from 0 to 9. Different letters represent different numbers, so it's like a 1-to-1 mapping. Also, we have the specification that multi-digit numbers do not start with 0. That was also like a given thing. And actually, yeah, each clue is a number that is bigger than 0 in general. So yeah, with that out of the way, I'm terrified. Let's go ahead and start. I think immediately with the cipher like this, I am wondering, where is the 0? This should be something we should be able to see fairly easily usually, because a number cannot start with 0 and a single digit number cannot be 0. So like A is not 0, F is not 0. Let's see, A, C, D. I see a lot of B's in the second digit, but not in the first. E, F, G, H, I, J. So really, B is... Let's do this on the solution layer. B is the only digit that can be 0. Whoops, I messed up my layers a bit. But yeah, B is the only digit that can be 0, so let's mark that here. And let's get all the B's. I see A as the tens digit a lot, so I do think A is 1, but that is not something we can immediately say. The other thing that is catching my eye here for Japanese sums specifically is that a lot of times four groups is difficult to place in a 9-digit grid, especially in cases where that's like A, B. There's gonna be here, this is 10 or 20, or well, it can't be more than 20 because there's 2 ABs and this here. This could still technically be 2020 and then something small for E. But yeah, this needs to occupy at least 2 cells. And then E is another group that's like here or here. But that forces H and C to be 2 different groups at the bottom. So let's just say this is H. This is definitely an X. And this is equal to C. Similarly, for the 5th row here, we have H, I, A, C. AA is going to span 2 on the right side. And with that, we have to place H all the way on the left as a single thing here. It's not really a big deduction, but we can also say that H and C are definitely 1 to 7, right? Because the numbers that we can place into this grid are 1 to 7. There's an 8 and a 9 somewhere, and they cannot lead to a single cell. GIII and GIGG are interesting because one thing I do see here, for if the same number appears multiple times, only one of them can be a single cell group. The others have to be at least 2. And in a row which has 4 of these clues, That's interesting because, for example, for the eyes, we can have a single cell eye and then things that span multiple cells, and then there's only one cell available for the G here. So I'm gonna say that this is an X. And over here, we need a single cell thing that is equivalent to G. Down here at the bottom, this is also interesting because we sort of have the same thing, but the G's and the I's are reversed. So here, first we have, well, one thing we got to pay attention to here is we can't do an X in this spot because then this would make this a single cell reached equivalent to G, but then we'd have two G's in the left column. So there's actually an X here. We have two cells here that sum up to G on the left side. Let's do a dot pencil mark over here just to say that these are not X's. This is going to be an I, and there's definitely going to be something in those two cells. Let's also mark these ones at the top in the same sort of way. And we can also mark this cell here, I believe, because we have a 2-cell group in the middle, or like 2 or 3. It's definitely at least going to take this cell here. So what does that tell us? I guess for I and G, these have to be 5 to 7. Because if it's anything smaller than that, you cannot have multiple 2 sums that go to that number. Like if it's a 4, we can make 4 itself. We can make 1 3, but then how else do we sum up to 4? With 5 we have 5, we have 1 4, and we have 2 3. So something like that, yeah. What's next? I guess we can't say the same deduction about F and I because well, we can say there, I mean, never mind, it's just F, but we can say it's between 5 and 9. F is not, it's not like we have to have a single cell thing for F just yet. As for A, can it really be 20? I don't actually think so. Let's look at this AB column here. If it's 20, the best we can, yeah, we can just straight up not do 2 20s with a 1 7. I was thinking in terms of 1 9 earlier by accident, whoops, but with 1 7, the best 20 we can make is 7 6 5 2, and then we can't make another 20, so A is definitely 1. That's pretty much just a given, yeah. So let's mark all of these. I should have been a little bit more careful here and remembered the 1 7, whoops. And in the columns, there we go, that's all the 1s. Where do we go from here now? 10 and 10, that can definitely be 2 groups of 2, so there's no real restriction on the E just yet. We can definitely, here at the top, this should have been an earlier catch, but we can make an X in this spot because 10 cannot be a single cell, of course. That means the single cell I region is in the third column here. And then there's going to be two cell regions on the right. D is going to be bigger than I here because it's got to take I and something else. So we definitely go down at least one. This has got to be a part of the AJ, which is going to be bigger than 10. So we also do go one cell to the left. And then with this AE, that's going to be bigger than 10 as well. We have to go down to take something into that group. Now here, this cell is interesting because I think this is going to have to be a part of the C. It can't be a part of the second group. That means we're going to have to place the other three groups in these 6 cells to the right, and we've already established that AA, the 11, needs to take 2 cells at least, which means we have an X over here. Whichever number resolves to an H goes here. Whichever number resolves to a G goes here. And we also have 2 X's in these spots. We also, we have a given here that this is going to be a part of the 10 sum. This is also going to go to the left at least 1 cell. So this is going to be a part of the second AJ. I think we can make a cross in this spot on the right, because if we say we have a number here, right, then we have to have 2 continuous groups AJ here. But then we place all numbers from 1 to 7. Never mind, that's fine. This is, if we do, then that's sums up to 28 in total, which is still fine if it's 2 groups of 14. Right, with that being said, J is 2 to 4. Because we cannot have more than 24 in each row. And I mean, we cannot have more than 28 in each row or column. Same thing can be said for C. It's 2 to 4. 1 and 0 are already assigned. You know, I completely forgot about that deduction here. And with G, I think it's, does it have to be 5? It can be 6, because if we have 6 plus 6 plus 16, well, that's 18 plus 10, that's 28. That matches exactly. But G cannot be 7, because then we have 7 plus 7 plus 17, and that's 31. That's too much. So let's say 6 here. I think, right, for this G, if it's a single cell region over here, then it's going to be bad because there's another digit that corresponds to G on the left. So this is definitely 2 cells, which connects with this here. So we do go down at least 1 for the 10 clue. And now we can move F up to 6 to 9, because F, we have it spanning 3 cells here. Right, so it's 6 to 9. I guess I didn't really think too much about this, but if it's a 15, it's got to still, or a 16, it's got to span 3 cells or more, because we have 7 as the max number, so it's got to be 7, 6, and then 2 or 3 as the minimum. So it's either here or both of, or like all four of those cells. So we can do dots in these two cells, which means we can place an X over here and also say that this number is going to be equivalent to the G. Geez, this is, I already knew this was going to be mind-breaking, and I hate this. Well, but I hate this affectionately. You gotta understand. AC, this is going to, I should have seen this earlier, but this definitely goes down at least one, which means we have placed everything in this row here. And because we've placed 7 different numbers, we can also say that J is definitely going to be 4, because it's going to be all of the digits here, and they sum up to 28. So let's place the other 4s. We've got one here, we've got one here. Are those the only ones? Yeah, I think those are the only other clues that we have. Now this one at the top right, that's got to be an E. We have G, I, E, H, C as guaranteed digits, and A as well, because A is 1. So that means, let's just do a quick note here. 8, 9, the only candidates for that are F. I think D still works. H does not work anymore, J does not work anymore. That's right, because A and B and J are set. C is definitely 2 to 4. E is a single cell. We've already said stuff about G and I, and H is a single cell here. So D and F are 8 and 9, respectively. Or rather, they're restricted to 8 or 9. But that's the pair. So what does that tell us here? C is definitely 2 to 3 now that we've placed the 4. It's still possible for the C to be a 3 region if it's a 1, 2, I guess. I don't quite see another restriction on C just yet. Right, I see something, I cannot be a single cell region because otherwise it's going to be 2 I's in the third column. So this is going to be 2 and another 2 for the AA. And this one on the right is going to equal C. Let's do dots here just because we can. It's still possible for the 10s to be a 1, 2, 3, 4, but that does not leave enough space for the other 10s, so we're going to go ahead and make an X here. And that is going to give us our second 10 that goes down at least 1, and we know we have our E here. The bottom row is all connected, so we have something that's guaranteed to be in this spot for sure. Wait, why didn't I see this before? I said earlier that like the first digit is restricted, but I was also thinking in terms of 1 to 9 because that's the Japanese sums I'm used to. But we are 1 to 7 here. The largest digit, the largest clue that's possible is a 28, so H is 2. Hold on, my pen's not. I'm sorry, that was just a flub on my part. H is definitely 2. So that means we've got a 2 over here. 2's over here. Where else do we have an H? That's going to be a 2. To make the 10, it's got to connect down a little bit more. So it's definitely at least 3 cells. And to make a number that's at least... No, we can't make that deduction quite yet. But yeah, that means C is definitely 3. So let's place all of those. This is 13, 13, which means there is no 2 in this row, because all the digits there have to sum up to 26. And there's only one way to do that. There's also a 3 here. So let's enter that here. The E single, that can still be anything. Actually, since we have 2, 3 down here, I think we can deduce that the top... There's only one other way we can sum to 10 in 2 cells, and that is a 4, 6 pair. I guess let's just quickly mark that E is still 5 to 7. I think actually for the... We can do something more. We can say that E is 5 to 6, because if E is 7 and I is 5 to 7, how do we add stuff up to I? So E is definitely 5 to 6, and I is the only number here that can add up to 7. So let's get our 7s in these spots. Everywhere where there's an I. The HF, right, F we deduced was either 8 or 9, and this can't be 29 because it's 1 to 7, so this F is 8, which means the D is 9. We're almost done finding out our cipher over here. So only the G and the E we don't have yet. The rest we could fill out. All right, now that's filled out. Let's see. Well, for G, we also have E being smaller than G, so since we have E plus at least 1 here, so... Wait, no, never mind, that's I. My bad. It can still be either way there. 9, we need a 2 in that spot. And then we need a 12. Setting up to that. That means this is going to be a 5, 7 pair. No other way to make 12 in that range with 2 numbers. That means the numbers on the other side are going to be 1, 3, 4, 6, which perfectly matches up, right? 1, 3, 4, 6. We can say this is definitely going to be 3, 4, 6 because we cannot have a 1 in that group. I think this is 1, 3, 4 because we cannot have a 6 when G is 5 or 6. We also cannot have a 6 in this spot because then we can't get 2 more numbers to get it to equal 8. Now that the bottom is 28, guaranteed, we definitely have a cell in this spot and this spot because it's got to be a 7 region. That means this one down here is a 4. We've got our 10 in the middle still. That can still be 1, 3, 6. Or it can be... Actually, because there's no way to make a 2-cell region anymore now that the 7 is out of the picture for 3, 7, and the 6 and the 4 is out of the picture for 4, 6. So this has got to span 3 cells. We've got the 10 still, we've got the 13 still. For the 13, it's either going to be a 7, 6 or a 7, 1, 5, since we don't have a 2. I think both of those still work with the 10. Actually, I think 7, 1, 5 is interesting because we've got a 23 sum here, so there are 5 missing. If we have 7 and like, I don't know, a 5 and a 1 here, then our missing numbers are, to add up to 5, our missing numbers are either going to be 1, 4, but that's not possible, 2, 3, but that's not possible, or 5, but that's not possible. So this cannot be a 1, 5, it can't be a 2, 4, so it's got to be a 7, 6. Whoops, wrong layer. 7, 6, and an X. So the 2 goes out 1 more, but it can't go out 2 more, so this is a 2, 5, X. This has to be 3 groups going down, so this is an X, this is a 7. To make 11, this goes to a 4. To make 10, this goes to a 6. Let me just clean up my pencil marks a little bit here on the doodle layer. Right, that's much better. So now we've got 10E25 going down. So this has definitely got to be an E here now that we have an X in that spot. Since this is going to be 3 groups that total 8, these all have to be 2 groups. So we've got to have an X here. And I think that resolves the E, because if the E was a 6, then we'd need to have a 2, but there's another 2 in that column. So we now know E is 5. And we can fill out the rest of our cipher here with E as 5 and G as 6. I could have gotten this earlier with the right column too, because if this was E being 6, then these would have summed up to 26, and that's not going to work. Right, there's always multiple ways you can make deductions here. And now with that out of the way, we can fill in the G's and the E's a little bit more. This is now a 5, which means we have a 2 in this spot. The 6 being already here means we have a 4. That goes to a 6, that goes to a 3. I don't know why I did these pencil marks here, but that is supposed to be a 1, 3, 4. That's a mess. But that means this is now a 1, 4 pair. All right, corrected that a little bit. This was a G, so this is going to be a 6. Right, I don't need these numbers down, up here at the top anymore. If this is a 5 on the left, then it's going to be an 11 and need a 2. That does not work, so this is a 7. Whoops, wrong layer. This is a 7. There's an X underneath. There 5 is on the right. This goes to a 15, so we go 2 down. Of course, there's an 8, the cell's filled anyway. The 1, 4 pair here goes to an 11 clue, so that's obviously going to be a 4, that's going to be a 7. 1, 3, 4. There's got to be a single 6 region here, that's there. We have our 11, so this is X'd here. This right column sums up to 28, so we need 7 numbers. This second column here also sums up to 28, so we also need 7 numbers here. That gives us our 7 region on the bottom, so these two are X'd on the left. Oh yeah, we had a G here, that's a 6. Now this is going to be a 1-5 or a 2-4 on either side. There's 2s in the right column, so the 2-4 goes over to the left. And we can also resolve the 1-5 on the right. The missing ones here are a 7 and a 4 on the right side. There's a 4 at the bottom, so that's placeable. We got a 3. And we need a 1 and a 7 here, so that's doable too. Right, we marked this as an E, so that's a 5. And the missing number here is a 2. That's a 4, so there's an X above it. That's a 2, so we still do go up. This could be a 7 or it could be a 1-6. Either is still fine, I think. The 5 and the where's my pen? Shoot, this sometimes happens with the tablet where the pen just gets lost. There's a 3 here, and this other pair is a 1-7. 1-7, and we go down for a 5. There's a connection here. Right, we need to place everything besides 2, so we need 6 numbers. So that is also something. That means we have 2, 3, 1, 4, which we place like this because of the 4. We have a 6 here to make the 7. And for the 10, we make a 1, 3 going down. This needs a 1. And now we have a 6. And I think that's everything done. Wow. Oh, wait, one more. 3. Now everything's done. Awesome. Cool. And that is going to be it for this puzzle. That was pretty exhausting. But I think the general logic, I did skip over some deductions because of scanning problems. Oops, some bad, some things were on the pencil mark layer again. The multi-layer system is still a work in progress here. But we got everything done pretty nicely here. And I did thoroughly enjoy that solve. So thank you very much to WPF for writing this. And thank you so much for watching. I hope you got something out of this, and I will be back soon with more puzzles. Bye-bye.